Hello guys, welcome back to IT Father Academy, and today we are going to learn tutorials about how to implement DNS security in Windows Server 2012 R2. So here is a situation whereby to configure or to implement DNS security in Windows Server 2012 R2. So here we have some requirements here for the client. So the client A, we have Windows installed on it. We have assigned for static IP address and also joined to the domain, and it has 8 GB RAM, and the hard disk is 1 TB, and the processor is 1. And the client B to Windows installed, assigned for IP address, and joined to the domain, and it has 4 GB RAM, also 600 GB hard disk, and 1 processor. And also we have Windows Server here. That's 2012 R2, and it has its static IP address 192.168.1.201, and it rules. We have DNS server and web server, and client 2, and we have router and internet. So now let's start doing something. Okay, so before we start the step by step to implement the DNS security, let's go through a theory behind this technology. So as we all know, DNS is one of the most critical network service for any network, because there are many applications and services such as ADDS rely on DNS to resolve resource names to IP addresses. So without DNS, user authentications fail, and network-based resources and applications might become inaccessible. So for these reasons in mind, we need to manage and protect DNS. Since DNS is a critical network service, as a server administrator, you must protect it as much as possible. So a number of options are available for protecting the DNS server, including DNS cache locking, DNS socket pool, and the DNSSEC. So as a system administrator, managing the service, managing everything, managing the system, you are supposed to implement something. You have to do something that will protect the server, from theft or from spoofing and stuff. So if you're able to do that, there's no way the server can go down, or even anything can be taken off. Alright, so let's continue. Alright, so DNS cache locking. So cache locking is a Windows Server 2012 R2 security feature that allows you to control when information in the DNS cache can be overwritten. When a recursive DNS server responds to a query, it caches the result so that it can respond quickly if it receives another query requesting the same information. The period of time the DNS server keeps information in its cache is returned by the time to leave value for a resource record. So the DNS cache locking, what it means that we have DNS cache server there. So anytime, let's say anytime you request for, let's say itfather.com or itfather.org, so the DNS server doesn't know what anything like itfather.org or itfather academy, so it will also forward the information to another server. So when it returns the answer, the DNS cache server will also keep or have a cache of it, so that anytime maybe you come back and request for IT Father Academy, then you can also be query the requesting the same information. So this is how it is. So recursive DNS server. A recursive DNS server is a domain name system server that takes website name or URL, that's uniform resource locator, requests from users and checks the records attained from authoritative DNS servers for the associated IP address. So this one is clear for you. So what it means that a recursive DNS server is a domain name. Yes, just a domain name. So it's in the form of a URL. So anytime you request you request from users and checks the records attaining from authoritative DNS server for the associated IP address. So anytime you request for something in the form of either IP address or URL, that server also help so that you can easily find your answer. Alright, so this was the illustration. So you see here we have what requesting host, that's what yima.nit.edu, and the local DNS server dns.nit.edu. So anytime you request, so this was the host requesting from where? From here. Requesting from DNS server. So it also forward the request to what? The root DNS server. Root DNS server said, okay, me too, I don't know anything like ima.nit. So it also forward what? From root DNS server to what? Top level DNS server. It also doesn't know anything like that, so it also forward what? From top level to what? Authoritative DNS server. So authoritative DNS server found it, then return the answer to top level, also forward to root DNS and back to local DNS server. So that's it. So anytime you request something, that's how it go about it. Alright, so let's continue. Let's move to root hint. So if the DNS server does not know the address of the requested site, then it will forward the request to another DNS server, as I said earlier on. So anytime you request something, and the thing doesn't know it, it's technology is not like human beings. As maybe if I ask something, the person doesn't have some, instead of him to, or instead of for him to direct me to another place, he or she will try to get me another thing that's fake. But as technology, if you ask for IMA and the thing doesn't know anything like IMA or doesn't have some, he or she or the device will forward your request to another device. So let's say something here. In order to do so, the DNS server must know of the IP address of another DNS server that it can forward the request to. So this is the job of root hint. Root hint provide a list of IP address of DNS servers that are considered to be authoritative at the root level of the DNS hierarchy. So this is how it is. So the moment you request, so let's say you request what? IP of what? edu.com. So now it will forward your request to ISP DNS server. You see the procedure. So let's start from here. So this one. Then the moment you request, it will forward to DNS root server. After there, back to, so let's say maybe you request what? edu.com, and ISP DNS server doesn't know anything like that. It will forward your request to another server. That's it. So this is how it is. So then when the answer returns, then they also have a copy of it. So anytime you come back, then they'll just give you the copy of it. It's not just like going to type, do everything genuine. No, they have the copy already. So that's why anytime you use your phone to go to Google, then you type something, later when you go there, the moment you type A, the thing will just show up because you have already requested for that thing already. So the thing will just pop up, then you continue with your thing. So this is how it is. So let's move on. Also, recursive DNS servers are required to support the authoritative DNS servers, which would not otherwise be able to handle the log load created by the huge number of user requests. So recursive DNS servers further distribute this load to make website name requests supportable. So when a user types in www.yima.gh.com, for example, this address itself does not contain the direction to find the site on the internet. So it is only through DNS servers that the IP address is located and used to reach the site. Into bracket, unless the request has been made before from the computer and the response IP address has been cached locally. So as I said earlier on, so the moment you go to the site, then you type www.ima.gh.com. You see, this is how the process begins. So it's going to search for what? ima.gh.com. So the moment it finds it, then when it returns, then it's also keep the copy. That's what they said, unless the request has been made before from that computer and the response IP address has been cached locally. So when they have your copy. So the moment you type A, then the thing will just pop up, then you continue with your process. So this is how it is. Alright, let's move on. So now, how recursive works. So now we have preferred DNS server here, we have workstation, we have client machine here, we have DNS server here, we have root DNS server here, and we have .com DNS server and yima.com DNS server. So that's it. Okay, let's move on. So now let's move to DNS socket pool. The DNS socket pool enables a DNS server to use source port randomization when it issues DNS queries. When the DNS service starts, the server chooses a source port from a pool of sockets that are available for issuing queries. Instead of using a predictable source port, the DNS server uses a random port number that is selected from the DNS socket pool. The DNS socket pool makes cache tampering attacks more difficult because a malicious user must correctly guess both the source port of a DNS query and a random transaction ID to successfully run the attack. The DNS socket pool is enabled by default in Windows Server 2012 R2. So most of the times, you see, we have 2003 Windows Server, we have 8, and so the latest ones are 12, 16, and stuff. So there are some servers that maybe you can't get or you can't find some features from it. Some features like DNS server, DNS socket pool. Yeah, you see, they are saying what, instead of using a predictable source port, the DNS server uses a random port number that is selected from the DNS socket pool. The DNS socket pool makes cache tampering attacks more difficult because a malicious user must correctly guess both the source port of a DNS query and a random transaction ID to successfully run the attack. The DNS socket pool is enabled by default in Windows Server 2012. The question didn't say what from all the servers, only 2012 Windows Server. Yeah. Alright, so let's move on. So we are moving to DNS security. Yeah, so DNS security enables a DNS zone and all records in the zone to be signed cryptographically so that client computers can validate the DNS response. So DNS is often subject to various attacks such as spoofing and cache tampering. DNS security helps protect against these threats and provides more secure DNS infrastructure. So as a system administrator monitoring the system, you are supposed to protect the machine and make sure all information is supposed to be secure and well protected. So you see here they are saying the DNS security enables our DNS zone and all records in the zone to be signed cryptographically so that client computers can validate the DNS response. So DNS is often subject to various attacks such as spoofing. So spoofing and cache tampering. So you have to protect the system so that there will not be spoofing and cache tampering and other stuff. So let's move on. So let's discuss something little about the following. So DNS zone and spoofing and cache tampering. Alright, so let's start from DNS zone. A DNS zone is any distinct contiguous portion of the domain name space in the domain name system for which administrative responsibility has been delegated to a single manager. Yes, so we have root domain. So the root domain and the root domain, we have another branch. It's like we have administrator. Okay, let me come in general. We have president. So president and the president cannot work. He cannot go round and do his own work unless he appoints some MPs, assemblymen, assemblywomen, and stuff. So we have root domain as a president, and also an appointed 3 ministers. Yes, so we have .com, we have .net, we have .org. They are all under what? Domain. Yeah, so that's why we have gmail.com, yahoo.com, yima at and so on. Yeah, so we have .com, .net, .org. So they are all under what? Domain. So these are what the root of what? DNS zone. And also, yeah, we have that's it. So blog.cloud, example like blog.cloudflowers.com. That's it. So this is how it is. So let's move on. So this was DNS zone illustration. So this is how it is. So we have dot and we have what? Com. We have domain 1, domain 2, domain 3, and we have subdomain 1, subdomain 2, and subdomain 1 and 2 again. So subdomain 1 and 2, there was zone what? 2, and the whole body of what? Dot and com, domain 1, domain 2, domain 3, there was zone 1, and the other one is zone 3. So this is zone 2, this is zone 1, and this is zone 3. So note each zone has its own what? Zone file. So zone 2 includes domain 1, subdomains 1 and 2, and zone 3 only includes domain 3, subdomain 1. So let's move on. Okay, so this is our scenario given. So let's move on. Alright, so let's move to spoofing. So in the context of information security and especially network security, a spoofing attack is a situation in which a person or program successfully identifies as another by falsifying data to gain an ultimate advantage. Alright, so this is how it is. So they are saying what? In the context of what? Information security and especially network security, a spoofing attack is a situation in which a person or program successfully identifies as another by falsifying what? Data to gain an legitimate what? Advantage. So you see, attacker try to what? Access the DNS server. He also like give commands as a normal user, but you never knew maybe he or she was a theft. So they normally create fake websites like this one. So you see, the person what? Ingest fake DNS entry, and the client also issue what? Request to real website, and the request resolves to fake website. So this was fake website. That's it. So you have cache tampering. So DNS spoofing also refers to as DNS cache poison. It's a form of what? Computer security hacking in which corrupt domain name system data is introduced into the DNS resolver's what? Cache, causing the name server to return an incorrect result record. Example, an IP address. This results in what? Traffic being diverted to the attacker's computer or any other computer. So these are what? They have what? Clear off, because they can cause the machine what? Or the system even not being what? Secure. They are tests, they are what? Spoofing. So the spoofing also can what? Cause the machine something damage. Yeah, so as a system administrator, you have to what? Secure the machine anytime and always. Yes, you shouldn't leave the machine there just like that. So you have to secure the machine from theft. Alright, so this is how it is. So DNS cache poison process. So attacker try to access DNS server, then so this what they normally give out. So now let's go through a simple step how you as server administrator can implement DNS security. Note, without the configuration of DNS forwarder, it will not function or perform as well. So make sure DNS forwarder is being configured. Otherwise, there's no way the work is could be done. So let's move on. So first step on server 1, to configure DNS security. So open Server Manager, click Tools and open DNS Manager. In the DNS Manager, browse to your domain name, then right click domain name, click DNS security, and then click sign the zone. So this is how it is. So this is the diagram. So when you open your system manager, server manager, so I'm referring to Windows Server 2012 R2. So this is how the console looks like. So this is the Windows. So the moment you open Server Manager and then you click Tools, when you click Tools, then open DNS Manager. So this is how it looks like. Then you right click on what domain name, then click DNS security. That's it. So in the zone sign-in wizard interface, so click next. So we are configuring what DNS forwarder. On the sign-in option interface, click customize zone sign-in parameters and then click next. On the key master interface, ensure that the DNS server LON DC1 is selected as the key master and then click next. On the key sign key interface, click next. So on the key sign key interface, click add. On the new key sign key interface, click OK. So please spend some time to go through about the key properties on the new key signing key interface. Alright, so on the key signing key interface, click next. So on the zone sign key interface, click next. Here too, then you click next. So on the new zone sign key interface, click OK. Alright, next. So on the next secure interface, click next. So next secure is when the DNS response has no data to provide to the client. This record authenticates what? That the host does not exist. So when you select this, that's how it means. So the moment a client requests for data, this record authenticates what? That the host does not what? Exist. On the trust anchors interface, check the enable the distribution of trust anchors for this zone checkbox and then click next. A trust anchor is an authoritative entity that is represented by a public key. The trust anchor zone stores what? Pre-configured public keys that are associated with a specific zone. So on the sign-in and pooling parameters interface, click next. So on the DNS security extensions, click next and then click finish. Alright, so the DNS console, expand trust point, expand com, and then click your domain name. Ensure that the DNS key is what? The DNS key resource records display and that their status is valid. Okay, next, open group policy management, expand forest, then expand domains, expand the domain name here. Right click default domain policy and then click edit. So in the group policy management editor interface, under computer configuration, expand policies, expand window settings, and then click name. In the right pane under create rules, in the suffix box type adatium.com to apply the rule to the suffix of the namespace. Then select both the enable DNS security and this rule checkbox and the require DNS client to check that the name and address data has been validated by the DNS server checkbox, and then click create. So DNS socket pool. So in domain server, open Windows PowerShell and type get DNS server. So this command displays the current size of the DNS socket pool on the 4th line in the server settings section. Note that the current size is 2500. Please take note that the default DNS socket pool size is 2500. So when you configure the DNS socket pool, you can choose a size value from 0 to 10,000. Above that is invalid. Take note. So the larger the value, the greater the protection you have against DNS spoofing attacks. So the more you the more you add more, then the more you get more protection. That's it. So alright, let's move on. So now let's change the socket pool size to 3000. So you type this. These are what the commands. You type what? DNS CMD config socket pool size 3000. So then you restart your DNS server for the changes to take effect. So thirdly, configure the DNS cache locking. In Windows PowerShell, type get DNS server. This command will display the current percentage value of the DNS cache lock. So the DNS note that the current value is 100%. So this change cache lock value to 70%. Please take note that you configure cache locking as a percentage value. So DNS socket pool and cache locking. DNS security is designed to protect the DNS client name resolution queries from 4 DNS data, including DNS cache poison. Socket pool and cache locking are two more advanced configuration options that may help strengthen your DNS security. So DNS security pool, this feature allows the DNS server to use a random source port out of a pre-configured range when sending DNS queries, by not using the same port for each new DNS query. The socket pool improves protection against DNS cache poison attacks. So now the figure below shows how to use the DNS CMD tool to verify and configure the DNS socket pool size. So this is how it is. So cache locking. When cache locking is enabled, the DNS server will not allow cache records to be overwritten over the duration of the time to live value on the DNS record. So this feature protects the DNS cache records against possible DNS cache poison attacks by malicious users on the internet. Cache locking is configured as a percent value. Let's say that you set the cache locking value at 75. The DNS server will not overwrite a cache or entry for 75% of the duration of the time to live. So by default, the cache locking percent value is 100, meaning that cache entries will not be overwritten for the entire duration of the time to live. You can use the DNS CMD tool to configure cache locking on the Windows Server 2012 DNS server. So let's see figure below. So this is how it is. Noting, in this article we walk through the installation process of the DNS role using both Windows Server 2012 Server Manager and Windows PowerShell. We use DNS Manager Console, PowerShell, and DNS CMD to complete administrative tasks, and reviewed some advanced security features including Active Directory, integrated zones, DNS security, socket pool, and cache looking. So we'll end of our lesson for today. Please subscribe if you haven't done yet, and make sure you share to your friends. Comment if anything you don't understand. You can leave a comment for us to answer. Thank you very much for your time.